Hello everyone, welcome to the Mathematics of my channel. In this video, we are going to solve this interesting integral. Integral from 0 to infinity e to the minus phi times x square. Phi we know, golden ratio, plus e to the minus delta times x square. Delta we know, silver ratio, plus e to the minus gamma times x square. Gamma we know, Euler's Mascheroni constant. Okay, how to begin? Well, first I'm going to take the definition of gamma function. We know gamma of n is equal to integral from 0 to infinity x to the n minus 1 times e to the minus x dx. Okay, then for this integral I'm going to take a substitution. X is equal to a times t. Then if we differentiate, we have dx is equal to a times dt. So we have here gamma of n. So we can write gamma of n is equal to, now limit we know, also 0 to infinity. X we have a times t. So a times t raised to the n minus 1 times e to the minus a times t, and dx we know a times dt. Okay, let us simplify. Here we have a to the n minus 1, here a. So minus 1 plus 1 get cancelled, a to the n. So we can write here a to the n we know constant. So we can take outside of the integral sign, a to the n integral from 0 to infinity. Now we have here e to the minus at times, here we have t to the n minus 1 times dt. Okay, then for this integral I'm going to take another substitution. T is equal to x square. T is equal to x square. Then if we differentiate, we have dt is equal to 2 times x dx. Okay, then we can plug in here a to the n integral from also 0 to infinity. Now e to the minus a, now t we know x square times t again x square, so x raised to the 2n minus 2 times dt we know 2 times x dx. Okay, then these 2 we can take outside of the integral sign because it's a constant. So we have gamma of n is equal to 2 times a raised to the n integral from 0 to infinity. Now here e to the minus a times x square times here x to the 2n minus 2, here x to the 1 power, so 2n minus 1 times dx. Okay, then here we have n, here we have 2 times n. So instead of 2 times n, I'm going to plug in k. So we have here gamma of k over 2 is equal to 2 times now n we know here n is equal to k over 2. So 2 times a raised to the k over 2 integral from 0 to infinity e to the minus x square times x to the, now 2n we know k, so k minus 1 dx. Well, then these two we can take to left hand side. So 1/2 gamma of k over 2 times here a to the k over 2. So here a to the minus k over 2 is equal to integral from 0 to infinity e to the minus a times x square times x to the k minus 1 times dx. Well, then both side I'm going to differentiate with respect to k. So here 1/2 I'm going to rewrite gamma of k over 2 because we are going to apply product rule. Then the derivative of a to the minus k over 2 we know minus a to the k over 2 over 2 times natural log of 2 natural log of a, here a, natural log of a, then plus 1/2, then rewrite a to the minus k over 2, then derivative of gamma of k over 2 we know 1 half gamma dash of k over 2, and we know this is equal to integral from 0 to infinity e to the minus ax square times x to the k minus 1 times natural log of x dx. Well, then we can simplify. Here we know a to the minus k over 2 and 2 times 2, 1 over 4 is a common factor. So we can take a to the minus k over 2 over 4 as a common factor. So here we have now gamma dash of k over 2, gamma dash of k over 2, then here minus gamma of k over 2 times, here we have natural log of a, and we know this is equal to our integral 0 to infinity e to the minus ax square times x to the k minus 1 times natural log of x dx. Okay, then I'm going to take 1. Okay, so when k is equal to 1, we have here a to the minus 1 half, so 1 over 4 times square root of a. Here we have gamma dash of 1 half minus gamma of 1 half times natural log of a is equal to integral from 0 to infinity e to the minus ax square times here k we know 1, so x to the 0 power 1 natural log of x dx. Okay, then now our integral from 0 to infinity e to the minus a times x square times natural log of x dx is equal to we know here 1 over 4 times the square root of a. Then we have gamma dash of 1 half. So how to find the gamma dash of 1 half? Well, we know the definition of digamma function. If we differentiate natural log of gamma of x, gamma function, we know this is equal to digamma of x. Then if we differentiate natural log gamma function, we know gamma dash of x over gamma of x is equal to digamma of x. Then gamma dash of x is equal to gamma of x times digamma of x. So if we plug in 1 half, gamma dash of 1 half is equal to gamma of 1 half times digamma of 1 half. Gamma of 1 half we know square root of 5, and digamma of 1 half we know minus gamma minus 2 times natural log of 2. So we can write here square root of pi times minus gamma minus 2 times natural log of 2. Then here gamma of 1 half we know square root of pi, so square root of pi times a. Okay, then we can write our integral from 0 to infinity e to the minus ax square times natural log of x dx is equal to here we can take minus sign as a factor, so minus 1 over 4 times here square root of 5 also a factor, common factor, so here square root of pi over a times now we have gamma plus 2 times natural log of 2 plus natural log of a. Gamma plus 2 times natural log of 2 plus natural log of a. Well, then let's take our main integral I. We know I is equal to integral from 0 to infinity e to the minus phi times x square plus e to the minus delta times x square plus e to the minus gamma times x square times natural log of 1 over x cube dx. Okay, then here we have natural log of 1 over x cube, so natural log of 1 over x cube we can write x to the minus 3 power, so minus 3 times natural log of x. Therefore our integral we can write minus 3 times integral from 0 to infinity e to the minus phi times x square times natural log of x plus here e to the minus delta times x square natural log of x dx plus e to the minus gamma times x square natural log of x then here we have dx. Okay, then we know we evaluate the integral e to the minus ax square times natural log of x dx. So here same type of integrals, so we can write the answer minus 3 times here we have minus 1 over 4. So minus 1 over 4 times here square root of pi. Here we have square root of a, so we can remove the square root of a to parentheses. So here we have now 1 over square root of a, so 1 over square root of a we know. Now instead of a we have golden ratio phi, so square root of phi times now here gamma plus 2 times natural log of 2 plus natural log of, now instead of a we have golden ratio. So similarly we can write here we have 1 over silver ratio delta then gamma plus 2 times natural log of 2 plus natural log of delta. Then for this integral we have plus 1 over gamma we know Euler's Mascheroni constant. Here gamma plus 2 times natural log of 2 plus natural log of gamma. Okay, then we can simplify here 3 over 4 times square root of pi. Then here gamma times natural log of 2, gamma plus natural log of 2, gamma plus natural log of 2, sorry 2 times natural log of 2. So we have gamma plus 2 times natural log of 2 times here 1 over square root of p plus 1 over square root of delta plus 1 over square root of gamma. Then we have natural log of p, natural log of delta, natural log of gamma. So we have plus natural log of p over square root of p plus natural log of delta over square root of delta plus natural log of gamma over square root of gamma. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.